Hello all of you. Today we will answer the question why ethyl bromide when treated with aqueous KOH yields alcohol, but when the same is treated with alcoholic KOH the product we obtain is an alkene. If you look to this equation, the only change we are having is the medium from aqueous to alcoholic, and the products being formed are drastically apart. In one case we are getting an alcohol, in the other case we are getting an alkene. Didn't it ever strike you that why with just a slight change of medium the products are changing so drastically? So let's answer this question. Why is it so? To answer this question, the first thing we'll have to take a note is the medium. The difference between an alcoholic medium and an aqueous medium. Aqueous medium we all know symbolizes for a water-based medium, and an alcoholic medium is represented as this, wherein R group represents any alkyl molecule in this case. For example, I am taking methyl alcohol. Now, what is the type of inductive effect that an alkyl group shows? It should be plus I effect. Here, I stands for inductive, plus means electron pushing effect. Inductive effect is an effect in which molecules push the shared pairs of electrons via the sigma bond. Now, what's happening? If these bonded electrons are pushed more towards oxygen molecule. In this case, hydrogen is not showing any plus I effect, but the methyl is showing. What will happen? The amount of delta negative charge on this oxygen atom here will be comparatively larger than the amount of delta negative charge lying in the oxygen of water molecule. What will be the effect of this? This is more negative, this is a positive species. This is slightly negative, a positive species. This bond should be stronger, and a stronger bond is more difficult to break. So this medium will be less acidic, this medium will be more acidic. In other words, this one will be a stronger medium as compared to this. Now just take a look at the products formed. Here there is just a replacement of bromine molecule with an OH group. In this case, what is being replaced, or rather what is being eliminated? One bromine and one hydrogen. So the type of reaction over here is substitution. The type of reaction over here is elimination. Now, the second part of this answering this question why, we'll have to take a look at the transition states formed when a substitution and elimination reaction takes place. So, let us consider, I'm just erasing this part also. Let us consider SN2 mechanism. What happens in an SN2 mechanism? A carbon atom is present. There are 4 bonds of this carbon atom. Let's suppose this is L represents your leaving group. Leaving group carries a delta negative charge. Carbon carries a delta positive charge. And if I am saying N, this N symbolizes what? Nucleophilic. So a nucleophile group carrying either a lone pair of electron or a negative charge will prefer the soft center carbon atom. Due to this attack, what will happen? This bond will weaken. So the next step will be the formation of the intermediate. Not intermediate, it will be transition state. The formation of transition state. How will it look? Carbon atom, slight interaction with nucleophile. This bond has weakened up. Here you have the 2 bonds which are already there. Here the 3rd bond, and this hashtag represents what? Transition state. Now compare what happens in an elimination reaction. Carbon, the 2 bonds. This supposes the hydrogen which is eliminated from here. The next carbon, CH2, and the leaving group over here is what? Bromine, L. what will happen over here? In this case, first a base molecule will come. In this case, the base is what? OH minus, which is coming from KOH. So the base molecule will first attack this hydrogen. Base, you see, is a strong thing. It will prefer a strong group, hydrogen. Nucleophile is a weak one, having a soft center. It will prefer a softer carbon atom. Due to this attack, this bond will lie down here. This bond will then get eliminated. What will happen in the transition state? Base molecule, slight interaction with hydrogen, slightly carbon, the two bonds. Next, slight interaction here, CH2, this bond is getting weakened up. Just take a look at the transition state. The two electrons coming from nucleophile, in a rough language we can say these two electrons are getting distributed between three centers. What are those three centers? The nucleophile, the carbon atom and the leaving group. In this case, these two electrons of the base molecule is getting distributed over 5 centers. Base, hydrogen, carbon, carbon, leaving group. Now, if 2 thing is getting distributed among 3 and here 2 thing is getting distributed among 5. So we can say the density over here is less, the charge density. The charge density here should be C by 5. The charge density here should be C by 3. Higher charge density means stronger thing. We all know in chemistry there is a dictum of like likes like when you study the part of solvation. So a stronger transition state will be favored in what? A stronger medium. Which is a stronger medium? Aqueous medium. And a weaker transition state will be favored in a weaker medium. Which is the weaker medium? Alcoholic medium. So is this clear now? This is the reason why an alcohol favors elimination and formation of an alkene, whereas aqueous KOH favors substitution and formation of alcohol molecule. Okay. Now, if there are any more reactions which you want me to explain or to answer to your questions why, do comment in the comment section and do share if you did like this video and if I was able to clear your doubt regarding why is this happening. Thank you.